and it is really good to see you again. I'm looking forward to doing this video with you. In our last video, we learned about relational operators and how we use them to compose conditional statements, which we then evaluate as being either true or false. Using a truth table, we walked through several example statements with both conditional and logical operators. These statements were examples from our day-to-day life, such as, "It's hot but not sunny outside." Today we'll be building upon that theme by writing a day analyzer program. Here's the flowchart for it. As you can see, we're going to ask the user for that day's temperature, which we'll then use to predict any potential weather effects the user could expect from their day, and we'll also recommend any appropriate gear that they might want to take with them before leaving the house, such as an umbrella for rain. While building this program, we're going to learn about if-else statements, switches, scope, and get some practical experience writing up our conditional statements in C++. Time to hit the keyboard. Okay, before we jump into our coding, let's review our flowchart just so that we know what we're walking into and we can identify all the variables that we're going to need. Alright, so we can see that we're going to start our program off by giving the user a prompt to enter the current temperature. And in the following box, we can see that we're going to collect that using a cin command, which is going to initialize our variable temp. So that's one variable down for us. Next, we're going to show the user some menu options. They could press 1 to see the weather effects predicted at that day's temperature, or they could press 2 and they would see some recommendations for useful gear that could come in handy for those potential weather conditions. We're then going to collect their choice using a cin command, and that's going to initialize menu selection. So now that's 2 variables for us. So now at this point, we can begin processing the user's input, starting with temp. Depending on the value of temp, there are 3 paths that our program could take. Remember that in a flowchart, diamonds represent decisions, or, as we just learned in the last lesson, the evaluation of a conditional statement. In coding, these are known as if-else statements. If this, do that. Else, do this other thing. Let's check out the conditions that we'll be evaluating the value of temp against. Our first statement reads, if it's true that the value of temp is less than or equal to 40, then initialize gear to coat, hat, gloves, and jacket, and initialize weather to snow, sleet, and rain. Else, meaning that that condition returned false, go to the next evaluation, which would be to check and see if the value of temp is greater than or equal to 41, and also the value of temp is less than or equal to 80. If that's true, then gear is initialized to sunglasses, umbrella, and zip-up hoodie, and weather would be initialized to rain, wind, and excessive sun. Else, if temp is greater than 80, we initialize gear to hat, sunscreen, and hand fan, and weather would be initialized to excessive sun, drink water. Now, in the case that our final evaluation were to return false, we move on to our final else statement hanging out over here. This is just a cout statement that informs the user we may have gotten an incorrect input from them, so we couldn't process their request. Now, if you think about it though, pretty much any temperature that the user might put in, we have a condition that should catch it, right? Say, for example, they say it's like -10 outside, our less than or equal to 40 condition would catch that. If they say it's like 110 outside, our greater than 80 condition would catch that, right? Even though that we should be able to allow for any temperature the user would throw at us, it's always good practice just to have some sort of catch-all default, just in case they type in, let's say, a character or, a decimal or some other thing that our program can't process. So it's always best practice just to have that final else condition just in case. So what did we learn from this section of the flowchart? Well, we identified 2 new variables, gear and weather. Because these are being initialized to text values, that insinuates to us that they must be strings. We also learned that the values that those variables get initialized to are dependent upon the value of temperature, and this is the real benefit of conditional statements. We can control that dependent relationship. For example, weather would never include drink water unless the value of temp is greater than 80. After we've evaluated temp and initialized gear and weather to their appropriate values, we move into one more type of evaluation tool called a switch. A switch is similar to if-else because it evaluates the value of a variable, but rather than being able to check for a range like we just did with temp, switches can only check for equal to, and we call these cases. So case 1 means that that variable has a value of 1, case 2 means it has a value of 2, and so on. In this example, our switch is evaluating menu choice. When you're working with a switch, we say that it is switching on, so we're switching on menu choice, which means that we're going to check the value of menu choice to see if it matches any of our cases. If the value of menu choice is 1, we'll follow the case 1 path and display for the user the weather predictions that got initialized earlier based on the value of temp. If the user selects 2, then we'll display the gear recommendations. If they selected 3, which was the option to exit, we'll simply thank them for using the program and then exit. Finally, we have a default case. This is a catch-all, kind of like our final else from earlier. It's simply going to tell the user that we couldn't process their request. So if they see this message, that means that menu choice was not equal to 1, 2, or 3. None of our cases. So for us, in this situation, that's bad data. Once the correct switch output's been displayed, our program's going to end. So now, after reviewing our flowchart, we're ready to hit the keyboard. We've got an understanding of our program's flow and function, and we've identified all the variables that we're going to need to make that happen. Let's do it. All right, so here we are in Visual Studio. I've got our program structure set up, and I've included the string library since we know that we're going to need string variables. I did also include the variables that we identified from our flowchart. If you're following along, go ahead and pause now and resume when you get this all set up with us. So what's the first thing we need to start with? Well, according to our flowchart, we need to collect the temperature from the user, which means that we're going to need that set of cout and cin statements. And of course, we want to give them the instructions that we need them to give that to us in Fahrenheit. Remember, we always want to ask for our data in the way that we need it. Okay, and then our cin into temp. Now, I made temp a double because with degrees, it doesn't necessarily have to be a whole number, right? Like it could be, a decimal, and that would be totally fine. We can still evaluate them in that way. Next, we want to display a menu to the user. We want to ask them, what information do you want to know about this temp? But if you think about it from their side, we don't just want to barrel into that, right? So what I'm going to do is I'm going to thank the user for their input just to kind of confirm that we got it. Okay, and I'm going to start that on a new line, again, just for that user experience and a clean view over there. All right, and if we think back to our flowchart, option 1 was going to be to display any weather effects. So I'm going to start that on a new line, again, for that cleanliness. And then let's class this up here, guys, and I'm going to display back to them the temp that they gave us, just to confirm that we got it, and then it kind of personalized the experience for this one. So temp, and then after that, degrees. Excellent. And then for our second menu option, and again, I'm going to put that on a new line and make it look real good, was to display gear suggestions. So and again, we're going to show them kind of that temperature back. Degrees. Because if we just had a number, it would be a little strange, right? And then finally, we had one last option, and that's just to exit. And it's always good, guys. This is great practice. We're going to get into more in our next lesson with loops, but you always need to have a way for the user to escape from the program. So, okay, exit. Excellent. All right, and so now we're ready to collect that from them, but we just don't want to have a cin here. It can kind of look like the program froze up, and so we're just going to give one last prompt, again on its new line. All right, excellent. There we go. Okay, here we are. I'm going to go ahead and put in, let's say, like 92 degrees for our test data. Okay, very nice. Our menu looks great here. Now, if I enter a selection, one, obviously we haven't built that out yet, but this is looking real good, so we're good so far. Okay, back to it. But before we get into switching on menu selection, we need to set up our evaluations on temp so that weather and gear can be initialized correctly with the appropriate values. Now from our flowchart, we know that our first evaluation is if temp is less than or equal to 40, then we need to do these things. And we're going to code it up in pretty much that exact phrasing. So here I've got if, and then within our parentheses is where we're going to put our condition. And we need this again to say if, and then temp is less than or equal to 40. And then we just close this up, and I'm going to put what is called curly brackets here. Now guys, these are on your keyboard near the enter return key. You just hold down shift on the square bracket key there and it'll give you the curly version. All right, so I want to make a note about these curly brackets because they are very, very important in coding. From our flowchart, we know that if temp is indeed less than or equal to 40, so if this evaluation returns true, we want to initialize gear and weather. So I'm going to put here gear would be equal to and weather for a chilly day like this could be possibly snow, sleet, or rain. Okay, so if it's true that temp is less than or equal to 40, then this will happen. And we know that this will happen because these statements here are within the scope of this particular if statement. And that scope is indicated here with these curly brackets. Scope is incredibly important in programming because it dictates who is responsible for what. If you've ever heard someone say like, oh, that's not my job, it's usually in a scenario where they're refusing to do something outside of their assigned duties, right? And much like those curmudgeon coworkers, pretty much anything that we use in programming that has curly brackets, it's not going to be a team player. It's only going to execute its assigned work that is within its curly brackets when that condition is met as true. So in this example, our if statement's job description here is to initialize gear and weather to these values when temp is less than or equal to 40. Now, say that we ran this and temp was equal to 42. We got to this line. It goes to evaluate that statement. It's going to find it false. And our if statement is going to be like, yep, that's not my job. Bye, Felicia. Like, it's just going to nope out. And everything that's within these brackets is just going to be skipped. It's going to cut right to here and keep on going. In fact, y'all, this is so important that I'm actually going to derail us real quick just to show you what scope looks like in action. So I'm going to go ahead and comment all of this out just for convenience sake. This is also a great time to mention that Visual Studio has this awesome tool to mass comment out code. You can find it up here in your toolbar. It's this one right here. Comment out the selected lines. There's also the keyboard shortcut, Control+K or C. When we click that, okay, awesome, boom. Love that. And then you can undo it using the one next to it. I use that all the time. So let's go ahead and set temp to 42 like we were talking about in our example. And I'm not going to run this with the local Windows debugger because we want to see this come back as false. So I'm actually going to do our step into our F10 debugging. Okay, so now we're stepping through our program, and we know that because I have this little arrow right here that shows me where I am. And we can just continue to press F10 or our step over key to move through. And now here, temp is about to be initialized to 42. Once we execute this line, we'll see that appear down here in our autos window. So let's do it. Okay, there it is. Temp is 42, perfect. And now we're going to execute this line. If it were true, we would step into here and see gear and weather receive their values when they get initialized. But since this is going to be false, we're going to cut right down here. All right, here we go. See? It just skipped all that. Let's run this one more time. Let's run this one more time, but let's change the value of temp so that this returns true. So I'm going to go ahead and stop my debugging. And then let's change this, let's say 32. Okay. and do my F10. All right, here we are, and we're just going to step down. And again, because that's all commented, we're skipping it. Here we are. Temp is going to be initialized to 32. There it goes. Awesome. This is going to evaluate. Perfect. So now see how our arrow is hanging out on line 20 here? We're now working within the scope of this if statement. So gear, as we can see, has not yet been initialized because we're on that line. We can go to the next one. There it is. And then we finish up, and weather has its value as well. So I hope that helps illustrate just how important scope is. If you have major functionality in your program and you know you're going to need that to execute, then we also need to make sure to design our conditional statements to happen when we need it to. So with scope in mind, let's go ahead and get back to business. So I'm just going to delete this here, clean that up. And then this is another reason I love this commenting tool, is because it's just so easy to undo. All right, excellent. And we're right where we left off. So our next if statement from our flowchart says that we're checking to see if temp is greater than or equal to 41, and also less than, temp is less than or equal to 80. And then if that's true, within here, we want to initialize gear to sunglasses and umbrella or a zip-up hoodie, and weather for that temperature range could be rain, wind, or excessive sun. All right, excellent. But our flowchart also says that we should only evaluate this condition if this first one here returns false. As we have it right now, these two statements are going to be independently evaluated of each other. And what I mean by that is our first if statement is going to be evaluated, and then whether it was true or not, this second one is going to be evaluated. And that's because if statements come in a hierarchy of 3 forms. At the top, you have the pure if statement, which is what we've got right now. I'm going to show you the rest in just a minute. Just bear with me, hang on to that idea. So to create that connected effect from our flowchart where we only check this statement if this first one is false, we actually need to make this an else if statement. This is the second form of the if statement, and it is always preceded by a straight if statement. The else here tells our compiler that this should only be evaluated should this first one be false. Because we have the if here, it's important that we make a note that we also, whenever you're using if, you also have to include some sort of evaluation within there. So how this reads now is if temp is less than or equal to 40, do this, else, meaning that it was false, temp is not less than or equal to 40, evaluate temp for this condition. If that's true, do this. Does that make sense? It's the else that makes this second evaluation dependent upon this first one being evaluated as false. So that means for our third evaluation, we want it to be an else if too. And for this one, we're checking to see if temp is greater than 80. If it's true, we're going to do what's within here, which would be to set gear equal to and weather to all right, excellent. So that way, this very last one here is only going to be evaluated if the previous two were false. Because if this hits, if you think about it, that makes sense. If one of these is true, there's really no reason to check this because these conditions don't overlap. A temp can't be less than or equal to 80, but also greater than 80, right? Well, what happens now if all 3 of these were false? If temp didn't fall into any of these brackets that we've got? Well, in our flowchart, we saw that false took us out to a cout statement that informed the user we couldn't make the evaluation based on the data they gave us. So to put that here in code, we're going to do the third and final form of the if statement, which is just a solo else. So because else indicates to the compiler that there should be a preceding check before it gets there, this else statement is only going to execute should all 3 of these evaluations be false. So this is going to be our catch-all. Because we don't have an if as part of this if-else form, we don't have any sort of parentheses or evaluations here. So if we make it here, that means that all three of our previous evaluations were false, so we probably got some bad data. So we're just going to tell the user, sorry, we couldn't complete your request. Please enter valid menu selection. Okay, before we move on to our switch statement, let's just have a quick review of the three forms of if-else. So first you have if, it's at the top of the hierarchy. If statements are always evaluated as independent entities. Next, you have else if. This is the second in the hierarchy, and it can only be used following a straight if statement, and it must include some sort of conditional evaluation within its parentheses. Finally, the very last form at the bottom of our hierarchy is just the else statement. It does no evaluations, and it can only be used following an else if statement or just a straight if statement. At this point, if you're following along at home, I recommend that you pause the video and just step through your program a few times and make sure that when you enter temp, you can actually hit within the scope of all of these statements. All right, good modular testing practice. So the first time that you run, say you would enter 30, to try and hit here, then you could enter 50 and try and hit here, and then 90, and then some sort of just, junk data to see if this will catch it. Okay, for time's sake, I'm not going to do it in this video, but again, in the spirit of good habits, now would be the time to debug what we have so far before we continue. Okay, let's go ahead and switch gears and set up our next evaluation tool, which is the switch. Now, like I said before, a switch can only evaluate a variable to see if it's equal to something specific. And that something can only be an int or a char value. We can't switch on doubles or strings. The syntax for a switch looks like this. And within here, we're going to put the variable that we want to switch on, or the variable that we want to evaluate. And that is going to be menu selection. And just like our if-else statements, we need our curly brackets to tell the switch what its job description is. So everything that we have here between the curly brackets is the responsibility of our switch. This switch is going to be managing the user's selection from the menu that we displayed to them earlier in the program. So if they entered 1, they chose selection 1, which means that they want us to display the potential weather effects at their temperature. So let's go ahead and set up our first case for that. The case is a switch's way of saying the variable is equal to. So how this reads in English is if menu selection is equal to 1, and now we're here and we're going to tell it what we want it to do, and we need to tell the user, and we're going to put that on new line for display. And then let's show them the temp. Again, just to kind of reiterate that we know what we're talking about here with their particular data. Okay, and then we're going to call our weather. Excellent. Now, right after this, and not outside of the scope of the whole switch, but just on a new line, we're going to do break. So when using switches, it's the case that identifies what value we find acceptable. Whatever's between the colon and the break is within the scope of this case. So what we've got is this cout statement is within the scope of case 1, which is within the scope of our switch statement. This is called nested scope, and we're going to get into it more in the next video with loops. But for now, let's just keep moving forward. So what other menu values did we have there that would be acceptable? 2 and 3, right? So that means that we're going to need a case for 2 and a case for 3. And guys, what I'm doing here is setting up this infrastructure. I like to do that a lot. I find it's really helpful to just write out the case and then get that break there immediately. The break is really important, and I see a lot of students forget it. When we get to the break, it's just going to shoot us down here to the very bottom bracket, and we're going to skip the rest of the evaluations. If we forgot this and left it out, it would just continue down through the rest of the cases. Okay, so just make a note of that. So if the user did select 2, menu selection is equal to 2, then that means that they would like to see gear recommendations. So this one, it's going to be very similar, right, to weather. Okay. And then for 3 was exit. And we could just kind of kick them, out, but it's always nice to thank the user for using your program. Just that extra experience, right? Okay. And then we'd hit our break and we'd come out. Now, we had an else statement earlier to catch any bad data with our if-else arrangement. In a switch, we call that the default case. And you set it up just like any other case. You have a default and then your break. And this is the scope of the default case right here. And in this instance, it would be for bad data if we made it to this point. So we're just going to tell the user, now, just as a fun fact, when you're working with switches, a default case is not required. Just like when you're working with the if-else forms, if you just have an if, else is not required. But from a process standpoint, it's always smart just to have some sort of catch-all default for any sort of bad data that you might get for the user. So a switch really is a lot like if-else statements. If we had written this up as if-else, this is what it would look like. As you can see, it's pretty close, right? It's just that instead of having a range with the greater than, less than, or being able to combine multiple conditions, we can pretty much only check to see if it's equal to particular values. Because of that, we could create the same effect with if, else, or switch, but as developers, it's also up to us to choose the proper tool for the job. And as you can see, the switch is just a little bit cleaner, better solution. We're going to save our if, else for more advanced evaluations. All right, awesome. Since we're at the end of our flowchart, let's go ahead and run this baby and check out our work. All right, so for today's temperature, I'm going to go ahead and put in 46. All right, there it is, and it's displaying that for us. I'm going to go ahead and let's check our weather recommendation. All right, 46 degrees, rain, wind, or excessive sun. Yes, definitely, especially since we're here in Ohio, you never know what you're going to get. So I would go ahead and run this a few times, guys, and just test those different brackets, make sure it's all working. But this is a really excellent, clean, well-written program. Thanks so much for switching it up with me today, everyone. I hope this was a super helpful video. In the next one, we're going to be diving deeper into scope, as well as learning about how to use conditional statements to ensure that we always get good data from our user. In the meantime, if you want to be a developer, it is absolutely within the scope of your abilities. Go get it. I'll see you next time.